Hey, welcome. We are on episode 7. We're going to review our progress and the next steps for net control. I'm Ryan. I'm a senior engineer. We're going to be working on our net control application, entirely written in Go. And I've made some changes over the weekend to it. Um, Basically, every once in a while, you want to just get in, throw your headphones on, get in the flow, and just do a bunch of stuff. I had an opportunity to do that last night after the kids went to bed. And then on Friday, I was just in and out a bunch, so I didn't have a chance to do a live. But I had little bits of time, so I made lots of little improvements to things. I wanted to review them with you guys, and then we can talk about what comes next for net control. As honestly, the check-in page is starting to get to be in a pretty good spot. I'm pretty satisfied with the core functionality as it is. There's still some things to do on it. There's always improvements to make. Um, there's some additional features we want to add to it, but I think it's functional enough for now that I want to focus on other areas of the app. So let me show you what we've got, and we'll go from there. So I went ahead and I pulled in the rest of the um, design that I had made for this actual page, the full page. Now that the core functionality is functional, this is the page, the net report or the net check-in list or logbook, whatever term we want to use for the live stream we did last week, where we actually used the radio and uh, basically acted like a net control, tracking everything that was going on, which was cool. There's still a few things to do here, but let's see what we've got. So I pulled in some of the application Chrome here. So the branding is here. These are the different subsections of an individual net session which I want to have. The preamble is going to be the thing you say at the very beginning, that kicks the net off. It'll be something like CQ, 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 calling all amateur radio stations, so on and so forth. We heard that last week during the net, and hopefully either today or later in the week we'll be able to do another um, live test to see if we made improvements um, in performance and in behavior as far as using the application. I like to do that every so often. um, so that's the preamble. Check-ins is the page that we're looking at right now. Reports, we don't have that yet, but that you may have heard at the end of the net last week. Basically, it's a summary of everything that's happened in the net that gets passed along and centralized uh, in this case, because this net is part of a traffic system. The Southeast Florida traffic net passes their metrics and things like that, and any messages to the Florida traffic net or the Southeast traffic net for the southern Southeast United States, and so on. And it gets all collated and collected, supposedly up to the top. So there's reports from that. Of course, you need to have some settings for this, which are going to have to be locked behind permissions. You've seen this check-in list before. This form, we have our check-ins, we have our little hands to see something's been acknowledged or not, uh, the license status, all that sort of fun stuff. Um, then I pulled in some of this. This is the actual text from the SEFTN website about the description of the SEFTN, Southeast Florida Traffic Net. This is just a bunch of filler text just to get an idea for the UI. This is the actual schedule. It's not on the bottom right here. Um, Granted, this isn't coming from the database. This is all hard coded. Every single page will look the same, but that's okay for now. And then these are the actual radio settings. If you want to connect the primary, this is the frequency, the downlink and uplink frequencies for the repeater, as well as the tone that's needed to get the repeater going. And there's a backup as well in case the primary goes down. Um, and then we have our account up above. So this page works. In fact, it works pretty well. Let's go to our nets. Let's just go to a test net that we have going so we can see what's going on. Um, you can see hard-coded stuff. This works. It checks in, it gives a little thing that it's going, and then it actually shows the license information here. That all works, um, which is pretty neat, right? And we'll get into some nitty-gritty on that because I noticed some reliability issues or potential reliability issues. So we've made this very, very, very robust. Um, in some really, really cool ways. So we'll get into that in just a moment. But this does work. And since we're now using server sent events, let me go over here. This is another instance of it. View nets, awesome net 7. This is the same one. So I can put these side by side so you can see it, hopefully. Let's see. Will that work? Okay. We have two views into the same page. So now if I KD4 OVP, I can check them in. Oh, hey, look, it actually live updated in both places. Server sent events are great. So that's what that's doing. It's using a server sent event to update the page, which pushes that information to all clients who are viewing it, which is pretty cool. So that means that once we have permissions and stuff set up, um, so that we want to have permissions because if you're the net controller, you can check people in. If you're not the net controller, you shouldn't be able to check people in, or if you have permission to check people in. So sometimes there's someone whose role is to just do recording, in which case fill out the logbook so that net control can focus on managing the net and controlling who speaks and so on. Uh, they'll be able to do this, and other folks can monitor, see what's going on. Or maybe you're a member of the net, you want to see if you've been checked in, or if a certain person's on the net or not. You'll be able to view the page live, see the updates live. It didn't cost us really much of anything engineering wise to make that happen, and I think it's a really cool feature. It gives something special to it, uh, which I like. I think it's fun. Um, so I mean that, as you can see, the Chrome's not available anywhere else because it's literally just on this single net page. So we'll have to fancy this up as we go through these pages and figure out how we want to handle the Chrome here up above in a way that doesn't be a bunch of copy and paste. We want to avoid that. Uh, this is going to be here all the time. This bar is going to be here almost all the time. I think it's going to be here all the time. This account link is going to be here all the time, which you might not be able to see. So this is here, the account link on the top right. And but these things are going to change based on the context of the page. So we have to think about that a little bit. We have to think about it, which is fine. Now I wanted to talk briefly about some of the events and some of the refactoring that was done in order to make this all work, uh, because I think they're really, really freaking cool. Let me just in this because that's important. You need to be able to see there. That should be a little bit better. So, an important thing here, as we mentioned, is how we do the event handling. Now, okay, here we go. So, we've talked about this check in before, and there used to be a defer here that did stuff in the background. And that's great and all, but that always bothered me a little bit. Uh, One thing that bothered me about that is, let's see. That's not what I want to do. There we go. Sorry. So one thing that bothered me about this was, well, there's two things. We'll see. The first was, what happens when we want to have multiple things occur because of a single event? So for now, we were kicking off, or at least previously we're kicking off, and even at this moment, when a check-in occurs, we want validation to occur, right? And that's fine. And we want to do that in the background. So we would create the event, and when as soon as that's done, we would defer a go routine, which it's fine. Um, Not ideal. But we would defer a go routine that would create the validation event to say that something was validated or not, and then we'd bubble it up to the user, and so it would defer a server sent event that would then pass that on to the user. What if we wanted to add another event or some other handler that uh, listens for the check-in event or any event? Because remember, we're learning our patterns here as we go through this rather than try to come up with them all ahead of time. So it's important to think about not just our immediate use, but maybe the next use or the next two uses, and just keep that in mind as we engineer this. So instead of continuing this down this path of each event as it's created it should have the responsibility, or that service should have the responsibility of calling all of the things that we care about. So, for example, maybe we wanted to um, have a welcome to the site thing. The first time that you check in, we wanted the first time we ever see you check in ever, uh, we want to send an email to you saying, or something indicating, or either a UI element or an email saying, "Hey, welcome to the Southeast Florida Traffic Net. Welcome to my amazing net. Thanks for being here. First time, like, glad you're here. Thanks for coming." Or similarly, maybe we want to have it if we haven't seen them in a long time. Welcome back. Now, how would we do that? If we were to implement that, we'd have to go into the check-in method. We'd have to add a go routine there that goes ahead and adds this extra thing. So now the functionality, whenever we want to add something new, we have to always edit something old. That kind of violates casually, I think, some of the solid principles. But also, it's just messy. Think about how it look at code review time. If you're always touching old code, then you have a possibility to introduce bugs into things that are already functional. So we want to try to not touch it if we don't need to touch it. So maybe there is an architectural change that we could do that would prevent that from happening, right? We shouldn't need to edit old code when possible to add new functionality if we don't have to, right? Obviously, if you're going to add a function to an old feature, yeah, you're going to have to edit it. But if I want to have something net new, I should be able to kind of hook into that to add additional functionality, layer it on top without needing to get in there and get nitty gritty. That's number one. We're going to file that. The other thing we had to think about, um, which we now have our own function here to validate the check-in, and this is where that second thing actually comes into play. HamDB lookup, in this case, communicates with a third party, communicates with a service outside of our primary service, which is the net control application. And that third party in more general terms could be the database, could be the email service, which we'll have to address it there as well. It could be any other internally developed microservices that have their own lifetime and health checks, things like that. How do you prevent an issue with a third party from affecting your application? And that's an important thing that we have to make sure to engineer around. Because if a third party, if HamDB were to go offline or be under load or anything like that, or maybe they just say, "Hey, we're tired of you using our service," and they cut off access. How do we make it so that doesn't negatively impact our application or slow it down? We can't have things hanging. And since we're doing events, how do we make it that if we can't handle an event now, we don't lose it forever? Because let's think about the flow. Um, a check-in is heard. We need to answer the fact or respond to the fact that a check-in heard event occurred. And then we need to create a new event and we need to process that check-in heard. So how do we do that if we're not online or if we can't process it now? Or if we restart the application or something's not running. It's very interruptible because we have no way it happens in a lifetime. We have no way of knowing, hey, we missed some events. How do we reprocess those? How do we make sure that we don't lose that event and it's gone forever? And then we never can verify things and the application starts acting weird because that event's never going to come and it's just we have a whole bunch of unverified things going on that need verification. So that's problem number 2. And we're able to solve both using a couple interesting patterns, which we'll get into now. So the first one of how do we handle extending without modifying is you can notice there how is it that I'm going to split this real quick so you can see both. How do we get let me make sure this is here. So validate check-in is over here and check-in is on the left. These are the two service functions that are responsible that need to communicate. The one on the right needs to know the one on the left occurred, specifically this net check-in heard here. How do we do that? Well, we already kind of have a hook available to us, which is the creation of this event. What if we can have it that when the event is created, we can publish that event, broadcast that event to the validate check-in method, or in other terms, the validate check-in function can subscribe to the net check-in heard event to be notified when it occurs. It's a very common pattern. It's used all over the place. We already have the hook for it because we already have a service responsible for creating events. That's one of the nice things about having single responsibility principle and using a service to create these rather than directly going to the database. Because without changing in any large meaningful way, the check-in function and the check-in service responsible for receiving the check-in and acknowledge putting it in the database, we can add some cool functionality. So that means we need some sort of pub sub system or something like that. And so we're able to make one pretty simply, which let's jump into that real quick. And there's a bunch of extra stuff going on here, and we'll dive into that in a moment. Now when we create the event, we have this extra little line here, e.publish, that runs. Can I jump to this? Yeah, it's down here. That basically goes through all the subscribers, and we'll dive into all of this momentarily in a little more detail, and informs all of our subscribers that are subscribed to the net check and heard event, calling them and allowing them to execute to run whatever it is they want to run. So that decouples our different handlers of different events and allows us to build a very flexible system where different components can look for different events and handle them in kind. And we'll dig into that in just a moment because this thing also handles the sort of handles the other part. To point number 2, how do we make something reliable? So there's obviously this is a I won't say it's a completely solved problem, but it's a fairly solved problem. And there are wonderful tools that exist out there. Some like RabbitMQ, fantastic. Does its job. It's very reliable. Uh, it's a beast in its own way, and it has its own set of challenges that come in when you want to run a second service. So far, our application runs in a single binary. It's using SQLite, so it's running a single binary. Yeah, all the applications, everything is served from our single application. If we were to bring in RabbitMQ, that also think of the carry-on effects and the knock-on effects. We need to now run RabbitMQ locally or have multiple brokers, message brokers, all that sort of thing. It means we're going to have to start using Docker or something like that. We're going to have to deal with versioning of it, all the tooling around it. How do we make sure that it's online? How do we make sure that we can communicate with it? All that sort of stuff. It's also a third-party service. What if that goes offline? How do we handle if a third-party service that's I'll call it second party because it's us. Um, how do we handle that? Now we have when we think about deployment time and how we run the application, execute it for the real world, when we eventually deploy this thing, we have to have infrastructure. We can't just have a server running our app. We have to have infrastructure. We have to have RabbitMQ running. We have to either manage it ourselves, we have to deploy it ourselves, we have to have this other thing running, on-call schedules, all that sort of fun stuff. Obviously, it's just me, but um, or we pay someone else to do it. AWS's queuing service or a hosted RabbitMQ. There's a lot of extra things that go into that decision of let's just use RabbitMQ, which is great. If this ever got to the point where we needed more things than we could just work around for, and we needed RabbitMQ, like we actually really needed it, and it made engineering sense to add it, then those other effects might be worth it, but they do impact that decision. For now, I don't want to deal with it. I just want my application to run. I don't want to deal with managing RabbitMQ. I've done it in the past. It's just not necessary, and it just makes it harder to get running. But we can use some of the knowledge from how RabbitMQ works in some rudimentary way to implement just enough to make it so that we can get the reliability aspects that we're looking for our event bus, which is now our service became an event bus by adding a publish and subscribers and adding PubSub. We can add some of that reliability without a huge amount of impact and without having a lot of the extra things that go into it. I'm totally okay with using a third-party service. Don't get me wrong. I'm very mindful of the not invented here syndrome. Uh, but at the same time, we should be very careful about the decisions that we make. The lesson that I want to use specifically is the idea, and other things do this as well. I believe it's called tombstoning. A little bit gruesome word, but basically, the idea is I want to record the fact that I'm about to send an event, that I'm about to notify a subscriber. I want to record that in a durable way, right into the database. Then, if all goes well, I just get rid of it. I just delete. I basically say, hey, it was resolved. The worker or the subscriber was able to accomplish what I needed it to do, so I don't need to remember this anymore. Then, because now we have records of all the attempts that we make, if the subscriber has an error and returns an error, we're going to make it return an error, we can basically look up all of the events that we tried to publish and couldn't, and we just republish them. We can just send them again and let the subscriber handle it as they wanted to originally, and so the subscriber is none the wiser that last time it didn't work or something else happened that made it so that it couldn't receive the event because it just knows, hey, I got an event, I'm going to handle it. That ties into another component, and we'll get dig into the source code in just a moment, I promise. Is how do we make it now that we have the theoretically have the ability to have reliable event delivery, which that's what this tombstoning recovery token kind of thing gives us. How do we make it that if a third party service goes offline, because this is important, that we don't just keep hammering that third party service? We don't need to be jerks, right? We should detect that we're having errors and we're having failures communicating with some third party service for whatever reason, and we should stop trying to talk to them for a little while. Basically, a circuit breaker. Because we have reliable event delivery and because we can queue our events, which is what this tombstoning recovery token process does essentially, because it'll basically write to the database all the events that it can't deliver. Now we can implement a circuit breaker on top that we can wrap our calls inside of a circuit breaker. And if the circuit breaker trips, we're fine, right? The events will still they'll pile up. we're going to want to process them, and we want to be mindful of the fact that it could be 1,000 events or a million events that have just been stacking up, and we want to not slam the service that just recovered from some sort of outage. But now we can do that, and we end up getting this really cool, very, very reliable mechanism for events. So let's dig into the code of how this actually works a little bit. Okay, so when we let's go to our model for events, because we do have events stored in the database. We now introduce a recovered event, which is the original event, the name of the function that we have to publish it to, and an ID in the database. It's very small. The actual migration for this is very small. All we have is an ID, a string, and an ID, an event ID, and a string, and we can see our queries for it also are pretty straightforward. We can, oops, that's net. Sorry, not that. Come on. There we go. We can get our recoverable events, which is a join, relatively simple query. We're just going to pull out our recovery ID and our registered function for everything that's inside of the events recovery table. We can create a recovery event, in which case we just want to store that information and we can delete it. Relatively simple functionality there. That works. Now, in our, we now need two other components. We need a subscriber and we need a way to publish. So let's let's focus on registration right now. You can register an event, and we want to say that our event handler, our subscriber, our registrant needs to take a context and an event model, because the event model includes, if we look at that, when it actually occurred, if there's any streams associated with it, the stream of it, the account that created it, the name of the event, and the actual event itself as a Go struct, not as some sort of interface, not as binary bytes or gobs or anything else that's crazy or JSON. It's the actual event. So it's in a usable form, and it needs to return an error. So when we register the event, register for it, yes, we're doing some reflection to get the name of the function. I'm okay with that. Reflection should always be something that you think about twice, because the idea is you register for the event as the system starts. That's the intention. That when you do an init, when the application starts up, we're going to do all the registration, get all that going, get all that wired up. It's happening once at the beginning. We don't do it again. We're not going to be doing it a bunch. So in this case, it's okay. I'm okay with it. Then we just add it to a map that we just basically have a subscriber with a func name and a function. And so this way we know the event that we care about and who we're sending it and who we're sending it to. And we need the func name because our recovery event and our database record, that's how we identify who the callers are. And we'll have to eventually deal with what happens if the function is deleted and there's still events in the system. We probably just need to make those gone. Um, so that's an edge case. We'll get to that. So that's registration. And if you note, and we can look in our net service, we have an init here where we actually just create just, okay, cool. We register for an event to validate net check and heard, and we can handle it. It's just handled just like before, really. Um, we, in this case, notice there's validate check-in, which actually does a validation, and we add this validate check in her to indicate that we want to deal with we're validating an event. We create a model and we ultimately execute our validate check-in. This way, the reason I split it up like this is if there's other parts of the application, for example, on sign up, where I want to do a validation, we can actually do that. Cool. That works or that exists, right? Event register. And we saw we had event create, which up above on the left here calls publish. So this gets a little, there's a lot of logging here. It's a little simpler, I think, um, here. So we create this internal, a work group. A work group is a package of mine. It just marries the idea of like a wait group and an error group and a few other packages together to make it so that you can manage your um, concurrency. So I chose an arbitrary 5. We probably should whoa, make this configurable. We probably should be able to pull this configuration out of the config to say how many concurrent uh, subscribers should be informed, which is fine. If we don't have any subscribers, we don't do anything. It's a no op. We're good. There's some extra logging stuff here. I like the fact that I can just add a bunch of context to the logger with this. I by convention, I use L for my local logger, and we have to create a new context. Again, I made this make. I just chose arbitrarily. We have a minute, so the um, consumers, the subscribers in this case, they have a minute to do their work. It probably should be shorter, but again, we can make that configurable. Right now, it's just hard coded. It's okay for now. It's just a safety mechanism to make sure that things don't just run forever. Then we go through every subscriber that we have for the given event, if there are any. Obviously, we already checked if there are, so there could be at least one. And then we use our wait group to say to run, manage concurrency. We make sure that we actually are we acquire. So one of the nice things about a work group is if we wanted to, it's not really used here, but it's a weighted semaphore. It uses a weighted semaphore. So if a particular function was heavier or harder or more expensive, we could actually make it so that uh, a when you register, you can say, "Hey, this is a really expensive process. I need 4 tokens." And even though we have a 5 as our the number of semaphores available, we can take 4 of them away, and that will help make sure that we're not overloading the system and we scale. But for now, we just need 1. Then, as we discussed earlier, we create our recovery token or tombstone. I'll use those terms interchangeably. Um, so we create that. Cool. And we of course have to check that we can actually write to the database. There's some error handling there. Fine. Then we actually publish the event. So by publishing the event, we execute the subscribed function. Cool. We passed it in our context. We passed it in our event. We're all hunky dory. If there's an error, we just return the error, and that will basically bubble up and come through because this work wait group has the ability to handle errors for us and pass them along. So we're good. And if we didn't have an error, we just delete the recovery event, right? So it's exactly like we described. Tombstone, execute, clear the tombstone, clear that token. That makes it so that we're reliable ish. That gets us halfway there, or more than halfway there. Next, we need the ability to recover those events, right? This is that second part. So now we have the ability to, if something went wrong, we didn't lose the event, cool. Now we need to recover it. So recovery, very, very similar. A lot of this code is the same. We could pull it out and to make it so that the execution is the same. I use the rule of 3, which is if you have to do it the second time, copy it. You have to do it a third time, consider pulling it out, and you have to do basically more than that. more than 3 times, pull it out to its own function, make it a little more general. Uh, in this case, it's not too bad. So we look for any recoverable events. We don't have any, we're done, right? This actually should have a if we don't have any recover events, we can return. Then we actually go through the business of recovering the events. Again, we make similar to before, make this configurable. Cool, cool, cool. And we just make sure that the event that we're looking at, so we go through every recovered event that we have, we go through every subscriber that we have. And this is where we would deal with the I have an event for a subscriber that doesn't exist. Um, sort of deal. We if it's not the one we're looking at, this is if this is not the droid we're looking for, we go ahead, we skip it. We're fine. Then we do a little bit more. This looks very similar to before. We make sure that we acquire the semaphore. So we play nicely. We publish it. We execute the function, and then we delete the recovery event, just like before. And then we return any errors that come from that. That's cool. So now we can recover events on demand, which brings us to the next challenge. Now we need to demand it. um, so we make a very simple recovery service. There's these two functions that are the recovery service here, uh, and they work together. Partly because everything that you start, a rule with concurrency, if you have the ability to start something, you should know when it ends. So I want to make sure that it ends. So we have a stop channel and we create a ticker for every. Now this is configurable in this way in our main function when we start it up. We can just either look to the database or hard code it or whatever. Config is probably better. Saying every period of time, we're going to head and just run that recover function. Pretty straightforward. So that's exactly what we do. We have our context, which we're going to be recreating. Uh, and something to keep in mind since we are running stuff in the background, and because we're passing a context in, this all plays together. This is why we have context and things. We can make it so the context now has a deadline, and that deadline is when the next tick is coming. So if we want to run a recovery every 5-10 minutes, we don't want recovery to have two things running at once. That could cause issues, right? Because we're going to find the same events that have yet to be recovered. We're going to double call things. It creates a whole host of issues if we aren't mindful of the fact that things can take a while. So we're going to update our context saying, hey, you've got this much time to do everything you need. We execute recovery and we throw some error logs, some logs in the system if recovery couldn't complete. And if we stop things, we cancel everything that's running because we have that context with a deadline. It's cancelable, so we can actually broadcast to all of the running functions. You got to stop your work now, or you're done. We do that, and we close a stop channel because this is the message we received. Also, generally, the rule is um, you want to be mindful who closes what. The receiver itself should be the closing, I believe, is the rule. And then we ultimately just finish because we are running in a Go routine that is an infinite loop, but we're selecting. We're doing a for select on a couple channels, and whichever message we get, we're good. So we shut down every subscriber and we close it, and then the stop recovery service is the one that actually sends those messages. So this way, when the application's shutting down, it can broadcast saying, "Hey, we need to turn things off." So we handle the fact if we're not running, we're stopped, so we're good, right? Um, log the fact that we're stopping, and then we do the necessary things to send the right messages to say, "Hey, we're shutting down. We're good. Cool." and we can set that up. You can see it set up in here we go. This is our entry point to the application. We on line 49 here, we start it every 5 seconds. We'll add a to do here, make this configurable. And we also, there's actually another to do here. We want to add a flag. I want to add a flag to skip the recovery completely. Maybe we don't want to do that right now. Uh, Maybe we just want to disable it because for whatever reason, that's just how we want to do things. And we also can have it um, to do perform recovery. This way, when the system starts up, when the application boots, it starts recovering those events before coming fully online, uh, which is cool. We and this way we use a skip recovery flag to disable that. Um, and this way we can decide when we want to recover events because as it stands, I think we can reconfigure this on the fly. Uh, but I'm just thinking about the scenario of, let's say HamDB goes down and we can't validate anything, and we find out about it a week later, and we go, "Oh boy, there's a million events. This is gonna be a long time before we can get back online." And maybe what we've done is, in the meantime, we've pushed new code to, um, I don't know, use a different service. We don't need those events anymore. So we'll have to add some tooling to purge those events, view what's available, again, for logging, monitoring, observability, all those things to make sure that we are handling these things appropriately and we don't get into a situation where we can't even start the application because it's bogged down doing recovery. We have to be mindful of that. So we'll add a flag for it. We'll handle that. For now, we're not at a stage where we need to worry about it, but there's a to do here. We will do this because it's an important part of being a good citizen. So that brings us to that last part, which I spoke about, which was how do we save our work there? Circuit breakers. These are important things. So we add an event uh, breaker. Well, let's go to our net real quick on the left here. Uh, Notice that, come on, let's go. We have a breaker service, breaker.call with hamdb, and there's also something here, add with consecutive, which also should be configurable. We have a lot of make this configurable to dos here. Cool. And what this does is calls the HamDB circuit breaker with this function, and this function only can return an error. That's why we have to wrap it. But validate checkin returns an error, so we're all play together. We're all hunky dory here, and we're able to continue basically wrapping functionality and layering it on top. And here we go, breaker. And I'm going to pull this up on the right instead, so we can see how they play together. Cool. So we have just some stat stuff that I've been playing with, which is fine. We will make that Prometheus or something in the future. We define our new service. We set up our service. These are some logging events so we can track in our logs when breakers are tripping, which it always tripped me up a little bit, no pun intended, that an open breaker is bad and a closed breaker is good. But it's think of it like a circuit breaker in your house. A closed breaker is a closed circuit, in which case it functions. And when there's a fault, either a ground fault or a short or overcurrent, whatever conditions make a breaker trip, it trips and it opens the circuit, and the circuit's open, no current can flow, and the system stops. So I just chose to use a package. It's very simple. It's a little outdated, but it's simple by this dude Rubyist called Circuit Breaker. I looked at a few of them that more Hystrix compatible and all these other things. They were a little more complicated. Again, didn't need all that. And I sat down to start writing a circuit breaker. And then when I saw this, I went, that's kind of what I would end up writing. So I went with that. Granted, because we're using a service, we can break this out and we can replace it anytime we want. If we need to use Hystrix or some more complicated, not the right word, more robust, the same way like with RabbitMQ. If we were to use Hystrix, uh, we'd have to set up a Hystrix server, more things to maintain. We don't need that right now. We don't need that noise. So for now, we're just going to use this, which is okay. So we have some housekeeping stuff, adding the breaker. It has the ability to add different types of breakers. So add just has a breaker that's always there. It's got someone took a quarter and shoved it where the breaker goes or a piece of wire, so it'll never trip. It cannot trip. Threshold means if you receive a certain number of errors, then open the breaker. Add with rate is a breaker that if let's say you receive a 5% error rate over 100 requests, then so we 0.95 and 100, then we want to open it then so that we allow some faults to come through. A little bit of errors are okay, but if we start receiving a lot of errors, trip the breaker. And the last is here that I have set up is a consecutive breaker, which is what we're using with HamDB right now. So the consecutive breaker is if you receive a certain number of failures in a row, then trip the breaker. So a single request failure, not that big a deal. Two request failures, in this case, it's set to hard coded to 5, but if you have a bunch of failures, a burst of failures, we're going to trip the breaker. Because our events are recoverable and the breaker will allow a certain amount of further calls every after a certain amount of time, it'll allow it to attempt one. If that doesn't work, it'll keep the breaker closed. Those are usually called half tripped or half open states. This supports that. So when it gets to half open, it'll be like, it might be working. Let's see if it recovered. And it'll go on. Um, because we have the recoverable events, the circuit breaker, it actually plays really nicely together and it will go ahead. And if there is a failure upstream, it'll trip and then the recovery thing will happen. And a few moments later, we'll try again. However often the recovery thing is set up. So that's pretty nice. Uh, and then so I have to wrap the call that calls that breaker, which receives our function, which we're using here on the left. And we basically just get the name. And if we don't have it, we create it. And I put a warning. I did this. It's a design decision. I can go either way on this. We could have an error when we do a call that, hey, the breaker doesn't exist. I don't like that so much because if I made a typo or a mistake, it's a runtime error. I could just panic. Again, that's a runtime error. Uh, I don't really have a way to do that. I suppose we could say is like we only use hard coded strings and or constants or something like that. But in this case, I just add it and make my life easier. And I put a warning. And this way, if we're in Datadog or we have some other cool logging tools when we get ready to run, if we ever find breaker not found, adding, we can have a warning saying, hey, this isn't a real breaker, something happened, this is where it came from, we should fix this. But it's not a stop the world sort of thing. It just means that we don't have an actual protection of a circuit breaker at this point. We can call OSHA and get it resolved, but whatever. And then also I added trip and reset, which I used mostly for testing at the beginning. Uh, but that would allow us, once we get there, we can add, let's say, an admin API or an administrative tool to basically say, turn off talking to the HamDB for a moment, turn off talking to our email server, turn it back on, whatever it is, we can stop it for a little bit, which is great. And that gives us control over those breakers. So, all that together means that we have a fairly robust system, I think. Um, I could add a bunch of tests to this, and we probably will, um, but the breaker implementation is tested fairly well. I'm satisfied with those tests. I probably can add a lot of tests around publishing. There are certainly edge cases, but I tested it manually for now. That satisfied me for the moment. Um, so that's neither here nor there. We're just doing that. Cool. Oh, okay. So let's make this go away for a minute. That brings us to our application. So what's next? I certainly could keep grinding on this. There's plenty to do here, but this is functionally, as far as I'm concerned, functionally complete. Let me rephrase that. It's usable, I think, right? We're getting into little fine tunings of things. All right. We have to make this bit on the right. We have to make that actually real, and managers and controllers and roles and all that sort of thing real. But to get that, we need organizations. All this stuff on the right needs to be not hard coded. That's something we certainly have to do. Time zones, we got to get that going. But all of these things rely, at least to my eyes, on accounts, which is where I want to focus next. So we need to make it. I already have login, which is great. That works. And I have some setup tasks to make sure if you're a new user, what's your call sign, what's your name, we get that information right up front. Cool. Can't edit it. That's fine. Can't change it. If my call sign changes, I can't change that. Um, and we notice in our events, there is the ability to have like who was the creator of the event, who triggered that. That's just hard coded to one right now because it's just not ready. Uh, we want to get that working so we actually have real audit trails. So all this leads me down to thinking accounts is what comes next. I want to focus on account profiles, editing accounts, organizations. Those things kind of play together. Our account model is really trivial right now. It just has basically an account ID. It has some foreign keys. There are foreign keys against account on call signs, on emails, um, and then it just has a name right now. It's really just name and ID. It's really simple. Um, and this week, and multiple email addresses, all that sort of stuff. So we need to get all that working, right? What I would like to do, the goal is I want to, as we build accounts, we need account editing, need that to work. I want to have a profile page. I want that to work because we have an ID. I want to make it that if you go to uh, the path will be, I don't know, station slash call sign, you get that person's profile because everyone has to have a call sign in order to use the system. That's cool. I also would like it that if that call sign is an organization, uh, if it's a club call sign, we can show a club page, club profile, and which means that that gets us the stuff that we need for our check-in page, which is going to be who's the manager, who are net controllers, and so on. And once we have those things in place, we can do a couple cool, really things. Um, One is permissions. Only people who are authorized to be a net controller on a specific net should be allowed to see this form up top, right? Not everyone should be able to check everyone in. That's just how it goes. Net controller, the person who is net control has ultimate authority. So in this case, in our UI example, uh, all these net controllers um, and managers or whomever, we have to play with our permissions thing. Um, all these folks, they're all the same person right now. They'd be allowed to see the net control page. Um, and we can deal with if someone's in net control, should someone else also be able to check folks in? How do we want that to flow? Maybe there's one net controller. Maybe someone can take over the net control because it's happened to me. I've been on my radio, da 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 da, taking check-ins, and midway through, my radio died. Something broke on it. I don't know. I I couldn't transmit anymore. I had to replace it. Um, Someone else who was a net controller realized that I was not responding and took over net control, right? They they acquired that. They forcibly acquired that, which is fine. Uh, but I'd like this to take care of that aspect. And as a bonus, if we're able to make this work, I'd be super happy. I'm gonna show you something, and I'll just show it to you. This is the homepage, the current homepage for the Southeast Florida Traffic Net. It's fine. It's a homepage. It's a little garish for my tastes, but that's fine. Um, it has the pertinent information. It's worked for them for a number of years. It tells you how to connect. It's just a bunch of HTML, but there are lots of broken links here. Um, this is how you find out who's the net control stations. This isn't necessarily up to date. Um, there's the check-in sheet uh, for it's just literally PDF of all the call signs of different things and how that works. Um, there's Is there a broken yeah, this is just all a bunch of interesting information, which is far too small for you to see, but, um, it's an old school page. It's a GeoCities-esque page. It's fine. But we'll have all this information here, right? We'll be able to say have the description. We know all the people, we know their schedule, we know everything. So wouldn't it be super awesome if we can make it that you can point to a C name or an A record to our site and show your page, show your profile. I have my callsign.net, so I have kk4jxi.net. I think that's might be .net or .com. I have to check. Why not have it go to my profile page in Net Control? That'd be cool. It can show the nets that I'm part of. It can show my activity, GitHub style with little pips. That would be super neat. And for an organization or a club, they don't have to deal with all the managing of a website. Uh, they can just have their club page kind of in net control. All the records are in net control. I think that would be super friendly, super awesome. So we'll get there. We're going to focus on, like I said, accounts and profiles and login, log out, and session management and all that sort of fun stuff. And we're going to say goodbye to this page for a little bit. So thanks for joining me here. It's been a little bit. Um, there's a lot of talking in this one, not so much coding. I appreciate you sticking around if you've made it this far. Uh, we'll see if schedule allows to do another live test with a net control uh, tracking, like net control managing the system with a real live ham radio net session. That should be fun if we can get that working. Um, Schedule allowing, like I said. Uh, and in the next one, we'll get into all the accounts and stuff. So thanks for joining this one. I'll catch you in the next one and stay frosty.